Good morning. Today we're going to be looking at trigonometry, which we just usually shorten to trig. And so our first question is, what is trigonometry? And trigonometry is just the study of triangle measurement. Okay, so don't let people fool you when they talk about trig. It's just studying the measurement of triangles. Okay, so in doing so, there are 6 different trig functions, but we're going to be looking at 3: sine, cosine, and tangent. Okay, so sine is the ratio of the leg opposite to the angle that you're looking at to the hypotenuse. Okay, so ratio of the leg opposite the angle to the hypotenuse. Okay, so the sine of A is listed as, okay, so if we're looking at the sine of angle A, okay, it is opposite and hypotenuse. So the opposite of angle A is the side length A over the hypotenuse. Remember, the hypotenuse is always across from the right angle, so C, so over C. Okay, now, if we're looking at the sine of B, so we're looking at this angle here, the opposite is side length B, always over the hypotenuse, which is again going to be C. Okay? And I'll show you an easier way to remember that in just a minute. But let's look at cosine. Okay, cosine is a little different. Cosine is the ratio of the leg adjacent to the angle and the hypotenuse. So the cosine of angle A is the adjacent side, which is the side beside it, which is B, over the hypotenuse, which is C. Okay? Remember, the hypotenuse is always across from the right angle. So it's going to be C in every case here. All right, then cosine of angle B, this is angle B, the cosine is the adjacent side, so that's A over C. Now, don't let it, C, hypotenuse, don't let it get confused, because C is also adjacent to B, but C is the hypotenuse always. Hypotenuse is 1, the longest side, and 2, across from the right angle. So across from that little box. Okay, so it can't be an adjacent or an opposite side. So you're always using either A or B. Okay, now the tangent, its formula is a little different. It's the ratio of the leg opposite the angle to the leg adjacent. So opposite and adjacent. So let's look. We don't even use the hypotenuse here. We're using the opposite and adjacent. So the tangent of A, angle A, the opposite is side A over adjacent, which is side B. Okay, and then if we are using angle B, looking for it, the opposite is B over adjacent, which is the side beside it, which is A. Okay, now, the easiest way and the most memorable way to remember our trig functions is SOHCAHTOA. It's a SOHCAHTOA. Okay, and here's what that stands for. That S is sine, and that OH means opposite over hypotenuse. Okay, opposite over hypotenuse. Let's write this differently. The opposite over the hypotenuse. Okay, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Say that in your head 10 times, maybe you'll remember it. Alright, C, that C stands for cosine, and then that AH is adjacent over hypotenuse. Okay, and you're going to make a fraction each time. Okay, and then TOA, the T stands for tangent, and the OA is opposite over adjacent. Okay? So let's look at how this works. Alright, if we are trying to find the sine of A, we're going to go to angle A first. Then if we're trying to find the sine, we go to SO, which means the sine of angle A is the opposite. So opposite over the hypotenuse. And the hypotenuse here is 13. Okay? So that's sine. So let's look at the cosine of A. Let's use a different color. Let's just erase these. Alright, so the cosine, we're looking at angle A again. The angle A, cosine, we're looking at adjacent over hypotenuse. So adjacent, that's the side beside it, so 12 over the hypotenuse, which is 13. Okay, remember, this is always going to be the hypotenuse. Okay, now adjacent and opposite change based on which angle we're looking at. Alright, now let's look at tangent of A. So we're still looking at angle A. The tangent is opposite over adjacent. So the opposite side is 5 over the adjacent side, which is 12. Okay? Now, if those would simplify, we would simplify them, but these don't simplify. So let's look at angle C. Okay, if we're looking for this, now again, hypotenuse is still going to be the same here. We're looking at the sine of C. So angle C is here. The sine is opposite over hypotenuse. So opposite is 12 over hypotenuse, which is always 13 in this picture. Alright, cosine of angle C. Cosine of angle C is adjacent over hypotenuse. So adjacent is 5. Hypotenuse again is 13. Okay, and then tangent of C. Tangent is opposite over adjacent. We're still looking at C. Opposite is 12 over adjacent, which is 5. Okay? Alright, so let's look at number 2. This does not give us the hypotenuse. Last week we learned how to find the hypotenuse by the Pythagorean theorem. Okay, so you should recognize that and be able to do that. So let's do the Pythagorean theorem. Alright, this is our C. Okay, because it's our hypotenuse, so we can make this A and we'll make this B. So remember, Pythagorean theorem is A squared plus B squared equals C squared. If you remember nothing else from this class, I think you'll remember A squared plus B squared plus C equals C squared and SOHCAHTOA, hopefully. Okay, so that's 9 squared plus 12 squared equals C squared. Okay, 9 squared is 81, 12 squared is 144, C squared is C squared. We're going to add those, and you get 225. And then remember, to get that C squared down to C, you take the square root, which cancels that out, and that's going to make C 15. Okay, so pause that, copy that down, and then I'm going to erase it so that I can put my hypotenuse where it goes. So C is 15. That's our hypotenuse. Alright, so if we are finding the sine of W, W is here. Sine, remember, is opposite over hypotenuse. Alright, so the opposite of W is 12. And we found the hypotenuse is 15. Now that will simplify. 3 will go into both of those 4 and 5 times. So that's simplest form. Alright, cosine is adjacent over hypotenuse. I'm not going to write that all out, but it's adjacent over hypotenuse. So if we're finding the cosine of W, adjacent is 9 over hypotenuse, which we know was 15. Again, that will simplify by 3, and you get 3/5. Alright, then tangent is opposite over adjacent. So opposite of W is 12 over the adjacent, which was 9. And again, that will simplify by 3. If you divide them both by 3, you get 4/3. Okay? So let's look at X. Okay, angle X, the sine of X, we're looking at X here. Sine, again, is opposite over hypotenuse. So opposite is 9. Hypotenuse is 15. That will simplify by 3. You get 3/5. Okay, the cosine is adjacent over hypotenuse. So the adjacent side is 12, and the hypotenuse, again, is 15. The 3 will go into both of those 4 and 5 times. And then the tangent of x is opposite over adjacent. So opposite is 9, and adjacent is 12. And that will simplify by 3. So if you divide them both by 3, you get 3/4. Okay. Hopefully you're catching on to this. We're going to do one more. This one didn't give us one of the side lengths. Okay, so this has got to be C. I'm going to make this one A, and we'll make this side length B. Okay, so let's find B. You got A squared, so 16 squared, plus B squared equals C squared, which is 34 squared. Okay, 16 squared is 256. Plus B squared equals 34 squared, which is 1,156. So we're going to subtract 256. And we get B squared equals 900. And then to get B by itself, we take the square root. And the square root of 900 is 30. Okay, so B is 30. That side length is 30. Okay? So now, once you find all the side lengths, then you can find sine and cosine and tangent of each angle. So sine of L is here. Sine is opposite over hypotenuse. So opposite is 30 over the hypotenuse, which is 34. That will simplify by 2. So that's 15 over 17 if you divide them both by 2. Alright, cosine of L is still here. Cosine is adjacent over hypotenuse. So the adjacent is 16 over the hypotenuse, which is 34. So if you divide both of those by 2, you get 8 over 17. And then the tangent of L is opposite, so 30 over adjacent, which is 16. And divide both of those by 2, and you get 15 over 8. Okay? And then we do the same thing for sine, cosine, tangent of M. So I'm going to erase these. B was 30. Okay, so the sine of M, we're looking here. Sine is opposite over hypotenuse. So opposite is 16. Hypotenuse is 34. Divide them both by 2, you get 8 over 17. Cosine is adjacent over hypotenuse. So the cosine of M, adjacent is 30 over hypotenuse, which is 34. Divide those both by 2, you get 15 over 17. And then the last one, tangent of M, is opposite, so 16 over adjacent, which is 30. Divide those both by 2, and you get 8 over 15. Okay, if you have any questions, let us know. Send us a message on Schoology. I think this is pretty simple. Tomorrow we will use it. We will use trig to find different side lengths. All right, hope you have a great day.